Okay. So if you're stuck on number 1, you probably first need to find AB. You probably need that first. And then use the fact that this is a diameter to find what they're actually asking you for, CB. Number 2, in order to find angle P, you probably first need to find arc RQ. That would be helpful. And then EH, you're trying to think, okay, between the 50 and the 42, which angle opens up to that arc? So just take a couple more minutes, work through those 3. I don't even bring my phone to lunch anymore because I just know that my brain.
What do I do? I want to go see the new car.
What are you with?
Good.
Yes. Sure. No, it's Haley this time. What's going on in your guys' world?
I just want to go see the new car. I just want to go see the new car. Dude, I think Caleb got caught with a weed.
Your mouth is so big, I can see down your throat.
Good one, Nick. Gosh, you're so clever. I got that on the spot. I can see down your throat.
Okay. We're going to move on. The first problem, who would like to walk me through what they did? Now, just remember, guys, if you're wrong, who cares? Nobody cares. Throw out your thoughts. Spencer, nobody cares if someone's wrong, except Mariah McCain, who's judgmental, apparently.
You said her on the mic.
Okay. Spencer is talking, and when Spencer talks, nobody else talks, please. Put your phones down. Spencer, proceed.
Okay. I realized that C to A is 180, and the arc across from C is 60, so I just did 180 plus 60, and then I think I got like 240, and then I minus it.
Okay, so he did it the way first hour did it, which is different than how fourth and fifth hour and I did it, but that's okay. So here's what Spencer did. It's not the only way to do it. Spencer said this is 60 because it's double the 30. All of this is 180. So then he took 180 plus 60 and got 240, took 360 minus 240 and got 120. Here's what I did. I knew this was 180, so I just took 180 minus 60 and got 120, which is fine too. Number 2, who would like to walk me through number 2? Nick?
I added 77 and 135.
Help me out here.
Calculator right now.
Okay, 212, and then proceed. Go on.
Check that.
I got. Okay.
I mean, you're not done.
So what you found was this.
What was I looking for? Oh.
And now cut it in half. And you get 74 degrees. My work got real sloppy. Sorry. So add up the two arcs, 77 and 135. Take it away from 360 and you get 148. But that's just the arc RQ. Half of 148 would be 74. Number 3. Who'd like to walk me through number 3? Tyler?
So we have to find EH.
Uh-huh.
And 42 opens, or EH opens, 42 opens. And double 42 is 84.
Good. The 42 is what opens up to EH, and then double 42 would be your answer. The only time where the angle directly equals the arc is when it's a central angle, which we have not talked about since section 2, so we're kind of done with that for a little while. Okay, questions on that so far? So we're going to add on to that today. There are 3 different scenarios for how lines could intersect with a circle. Let's make sure we are not texting and Snapchatting in between the lesson because we're moving forward now. 3 ways that 2 lines could intersect with a circle. They could intersect on the circle, like this one, and this is what we did yesterday and what we did just now. So if they intersect on the circle, and let's just say this is 40 degrees, then the arc across from it would be 80. The arc is double the angle. They could intersect inside the circle, like the middle picture, or they could intersect outside the circle, even though this picture looks like it's barely on the outside, it is. Okay? These are going to be our 2 new scenarios today. Now, before we get there, scenario number 1, if the vertex is on the circle. We did this yesterday, but this picture looks a little bit different now. Yesterday, we dealt with pictures that looked like this, where both of the lines were inside the circle. And so then this angle was half the arc. This picture is a little bit different because now one of the sides is inside the circle and one of the sides is on the outside of the circle. However, it works the same way. If that vertex is on the circle, it is half of the arc that it intersects, even though one of the lines is on the outside of the circle. But that arc, that angle still intersects all of this. So let's just say that arc was 120 degrees. Angle 1 would still be half of that, even though it looks different than it did yesterday. And same thing over here. If this over here was 240 degrees, angle 2 would be half of that. Now, what might happen today on your homework is they might give you like this arc measure and ask you to find angle 2. So a couple different relationships here to keep in mind. When you have a line on the outside like this, the red arc and the blue arc put together makes a full circle. So they have to add up and equal 360. And then 1 and 2 make a linear pair together. So those would have to add up and equal 180. But if that vertex is on the circle, even if it looks a little bit different, it's still exactly half of whatever the arc is. So on this first problem, this is the angle measure we're looking for. That vertex is on the circle, so that angle is just half of the arc it intersects, which is the 130. So what's half of 130? 65. That would be angle 1. Letter B, we're looking for this arc. That arc is intersected by this angle. Vertex is on the circle, so the arc is, or sorry, the angle is 1/2 of the arc. So how would I find my arc here? Double it. 125 doubled is 250. Remember, the arc is always bigger, always, than the angle. Questions? Okay, so the picture looks a little bit different, but still, if that vertex is on the circle, it is half of the angle, half of the arc that it intersects. Can't speak today. All right, new scenario though. What happens if the lines cross inside? and I'm being asked to find angle 1, okay? What we're tempted to do is take whatever this red arc is and cut it in half. But that's not how it works anymore, because this is not an inscribed angle. If that vertex is not on the circle, you cannot just cut the arc in half. It doesn't work that way. If it's inside the circle, then the angle measure equals 1/2 the arcs added together. Now let me kind of elaborate on that. The angle that I'm talking about is the angle that opens up to the arc that's marked. And then the arcs that I'm talking about are the arc that it intersects plus the arc behind it. So I call it the vertical arc. There's no such thing as vertical arcs, but we know what vertical angles look like. And so I'm talking about the arc that's like across from the vertical angle, if that makes sense. So I refer to them as vertical arcs, which is not a real thing, so I promise I'm not making stuff up, but I kind of am anyway. So the angle equals 1/2 the two arcs added together. So, for example, if this arc here was 70 degrees and this arc here was 40 degrees, this angle measure would not just be half of 70, it would be half of 70 plus the arc behind it, 40. So you'd have to add them together. Now, I wrote this down not for just kicks and giggles, right? I wrote it down because you should probably write it down. The angle equals 1/2 the arcs added together, because the angle's not always going to be a variable, so I don't want you to get used to that. Now, I'll let you know, too, that typically in years past on this chapter, because it is so huge, I have let students use note cards on this test. You have to fill it in and choose what you want to put on it, but lots of times people will put this on their note card, like angle equals 1/2 arc plus arc if it's inside the circle. And I use words like that because, again, it's not always the variable equals, like x equals. It's whatever the angle is. Okay, so in our first example here, now the catch with that is you have to use the angle that's actually opening up to one of the arcs marked, which this one is, so we're okay here. So our theorem, if it's inside the circle, is the angle equals 1/2 the arcs added together. So the arc that it intersects plus the arc behind it. Our angle here is x. The arc that it opens up to is 156, but it's not just half of 156, it's half of 156 plus the arc behind it, or its vertical arc, which is 130. What's 156 plus 130? What is it? 286. And then we still cut it in half. Half of 286. 143. Good. Now, the second one, and I realize I go from A to 4, but it must have been because I was too lazy to change that. The second one, you're still going to use this theorem, and we know what the two arcs are. So let's go ahead and get those plugged in on the other side of the equation. The two arcs are the 95 and the y. So let's get that plugged in. The two little arc pieces are the 95 and the y. Now, the angle, again, that I'm talking about, you have to use the angle that's actually opening up to one of the arcs. And it doesn't matter which angle, because vertical angles are the same size, so it wouldn't matter which one you use. But you have to use the angle that's actually opening up to one of the arcs. 102 is not opening up to one of those arcs marked. So we can't use 102. We need to use its linear pair, the arc right, or the angle right next to it. This is a linear pair together. Lines are how many degrees? 180. So let's take 180 minus the 102, and we get 78 for the angle that's actually opening up to the arcs, and that's what I'm going to use. You have to use the angle that's actually opening up to one of the arcs. Now, algebraically, you have a couple of different options here. Here's how I do it. Multiplying by 1/2 is the same as dividing by 2. And how do you undo division? You multiply. So I do it like this. I multiply by 2 on both sides and get rid of the fraction. And then I'm left with, so 78 times 2 is 56. There we go. Somebody first hour said, can't I distribute the 1/2 to the parentheses? And you certainly could. And then you would have 78 equals 47.5 plus 0.5y. And you could solve it that way too. It's kind of personal preference. And then our last step is to minus the 95 over. And what do I get for y? What is it? That's too small.
61.
What is it?
61.
61. You must have not, like, okay, when we multiply by 2, it cancels the 1/2. Questions on that one? Angle equals 1/2 the arcs added together. Okay, scenario number 3 then, when the lines meet outside of the circle. This time, instead of adding, we'll be subtracting. However, since for subtraction order matters, we have to make sure we copy this down correctly. The angle equals 1/2 the arcs subtracted, but you have to take the big arc minus the smaller arc. Now, the bigger arc will always be the arc further away from the vertex, because as an angle opens up, it the mouth of it gets bigger the more it goes on. So the arc further away will always be the bigger arc, and then the arc closest to the vertex will always be the smaller arc. Now, you have 3 different pictures here, but they all work the same way. The different pictures that you're seeing, the first picture on the left is when a secant and a tangent meet. So one side of the angle is inside the circle and one side of the angle is not. You still would take 1/2 the arc further away, so the red arc, minus the arc closest, the blue arc. And where they kind of separate is at that point of tangency. The middle picture, you have 2 tangents. Still works the same way. The angle is 1/2 the arc further away, so the bigger arc, minus the arc closest. And the reason you have to take the bigger arc minus the smaller arc is because if you do it backwards, then you will get a negative amount, which we don't deal with negative angles in this class. Again, where it kind of separates from big arc and small arc is right at the point of tangency, as you can see. And then the last one is a little more straightforward when you have 2 secants, so 2 lines inside the circle, you can clearly see the bigger arc minus the smaller arc being separated. So on these problems here, we don't need to write this down. Angle equals, whatever the angle may be, 1/2 the big arc minus the small arc. My parenthesis looks like a C. Big arc minus the small arc. So on the first problem, which of those degree measures is marking the angle measure? Someone just said it. X. Okay, that's your angle. Angle equals 1/2 the bigger arc, or the arc further away, minus the closer arc. So the arc further away is your 178, and your arc closer to the vertex is 76. And you can clearly see here that if you did it backwards, you would get a negative number, which we don't deal with negative angle measures. Okay, what's 178 minus 76?
22.
And half of 102? Good? And in the second example, which of those degree measures is the angle? 30, so it's not always the variable. One-half the bigger arc minus the smaller arc. So which, between the A and the 44, which one's the bigger arc? A. Good. Minus the smaller arc 44. Or the arc furthest minus the arc closest. All right, this is specifically where the person first star was like, can I distribute a 0.5 through? Sure, you can distribute the 1/2 through if you want to. I just personally, when I see the 1/2, I get rid of it. So I multiply by 2 on both sides to get rid of it. And then I'm just left with a minus 44 and 60 on the left. But if you were to distribute the 1/2 through, you would probably end up with the same thing, hopefully. Add 44 over, and I get A equals 104. So, in summary, when the vertex is on the circle, it is exactly half of the arc that it intersects. If the vertex is inside the circle, you have to add the arcs and then cut it in half. And if it's outside the circle, you have to subtract the arcs and cut it in half. Inside, add, outside, subtract. So go ahead, some of you already have, and get out the 10.5 worksheet. I just want to be weary of those of you that do your homework at the same time as notes, that you might not be doing it correctly and might be missing some key points. So just be cautious of that. Okay, where's my worksheet? Oh, lots of random markings. Here we go. I just want to show you a couple of things here. On number 11 on the back page, that looks like the Deathly Hallows symbol from Harry Potter. Or whatever you guys refer to as the Illuminati. I don't know what that is, though. But apparently this looks like it. Anyway, I want you guys to try those on your own. So I did have a couple people on their little reflections, right? Like, I'd like more challenging work. I'm not challenged enough in here. So this is kind of a challenge problem. See how many of these angle measures you can figure out on your own. And we'll go over it Tuesday, but try and figure that out on your own. But I wanted to go over just a few things on this worksheet. 1 through 4, that there's no addition and subtraction involved as far as like the 2 last formulas you went over. These are just exactly half of the arc that it intersects. So don't overthink it. And remember, like someone already asked me, AB, which one are you talking about? 2 letters is a minor arc. So when it asks for arc AB, it's looking for the smaller one. The only one here that's like not directly like a one-step process is number 4. So just make sure on number 4 you pay attention. They're asking you for angle 3. So if you cut 140 in half, that's good, but you need to find angle 3 in the end. I wanted to look at 6 and 10 real quick. So number 6, the lines cross inside. So we're going to use this formula. Angle equals 1/2 the arcs added together. Okay? The arcs are the 30 and the 2x minus 30. Now remember, the angle that you use has to be an angle opening up to one of the arcs marked. It doesn't matter which one because they're vertical angles, but it has to open up to one of the arcs. So we can't just use x here, unfortunately, because the angle x does not open up to one of these arcs. We need to write something in placement for that red angle there. Now, on the notes, we were given a number, so we just took like 180 minus 80 or whatever. We don't know how big x is, but the red angle still makes a linear pair with it, so it's going to be 180 minus whatever x is. So like if x was 100, then the red angle would be 80, because I would have taken 180 minus 100. So it's 180 minus whatever x is. But I can't just like decide what x is, unfortunately. So the angle is going to be 180 minus x. And then the arc that it opens up to is 2x minus 30. And we're going to add it to its vertical arc, or the arc behind it, 30. Now I'm going to help you kind of clean that algebra up a little bit. Parentheses first. I hope I'm not going too fast. Sorry. What's negative 30 plus 30? Nothing. 0. So those go away, and you're just left with 2x. What's half of 2x? 1x or x? So really what you're left with here is 180 minus x equals x. And now that should look a little bit cleaner to you, something you could solve. Your final answer should not be 0. And it should not be 180. So there you go. And then number 10 really quick. So if you can finish number 6, and then let's look at number 10. Number 10 is pretty straightforward, but we're just missing one of the arc measures. So now the vertex is outside, so we get the equation angle equals 1/2 the big arc minus the small arc. There's a part in my smartboard that's like, there's like a glitch in it, and so you see how like my writing gets all weird? I call it ghost writing. Doesn't it look like a ghost wrote it? Never mind. Okay. They laughed last year at that.
Sounds like it wrote itself.
Huh? Well, to Seth, it is kind of like it's writing itself. Yeah.
That's just Seth.
Okay, anyway. Our angle measure here is the 6x minus 11. The arc furthest away, the big arc, is all of this from y to z. Remember, the point where like the big arc and the small arc are cut off are at the points of tangency. We don't know that arc measure, but how could I find that arc measure? Say again? Just say it. Other way around, but yeah. 360 minus 125. We're the first class to get that without my assistance today. Very good. 360 minus 125. The full thing, the big arc and the small arc put together is the full circle. So what's 360 minus 125? 235, that would be the big arc. And then minus the small arc, which is 125. And now you should be able to do that one. Now, I'm sure some of you are already looking at number 9, going, what do I do with x over 2? If you are not comfortable with x over 2 and you don't like that, you are more than welcome to change it to 0.5x, because when you divide by 2, it's the same as multiplying by 1/2. So if you don't like the way it looks, like you don't like the x over 2 fraction, then change it to 0.5x, and then you might like that a little bit better. Keep in mind too, guys, on these algebraic expressions, when you subtract, you have to subtract the entire thing. You can't only subtract x, you have to also subtract 30. So sometimes when you write it out, it gets a little bit messy, but just make sure you're subtracting the whole thing. You still have 6 minutes, so please don't move, don't pack up, don't go to the bathroom, just work for 6 solid minutes. See how much you can get done before your weekend.
That's it, like no homework.
Miss Kennedy,
Mm-hmm.
I don't get how you finish off 6.